In this animation, we're going to look at the cycle of El Nino and La Nina. That is a pattern that occurs regularly in the Pacific Ocean and has a huge effect on climate and rainfall and other kinds of activity all around much of the world, especially around the Pacific Ocean. Now, in order to understand the development of these two conditions, El Nino and La Nina, let's take a look at what the normal situation is in the Pacific Ocean. Normally what happens is that you can see those reddish arrows there. You get these very strong southeast trade winds blowing from east to west across the Pacific. By the way, this is North America over here, South America. This red line represents the equator. This is Australia and New Guinea, and Asia would be out of view on this side. So as these trade winds blow, the air eventually rises in low pressure systems and creates a lot of rainfall over on the west side of the Pacific, over near Indonesia. And as that water, and what happens is a circulation cell called the Walker cell is set up here that it basically runs like that. Well, the effect of that is to push the water away from South America. Ocean surface currents are pushed this direction, and that takes warm water and pulls it away to the west, and it lets cold water come up from below. Here we have warm water, the thermocline, the big change from warm to cold, and then cold water down underneath. And as that wind blows and pulls the water away from South America, you tend to get cold upwelling water near South America. Meanwhile, a lot of very warm water accumulates over here in the western Pacific. It's called the West Pacific Warm Water Pool, because that water takes a long trip along the equator and it gets very warm in this area. So this is a part of the world that's very wet and warm and rainy, whereas this part of the world tends to be cool and drier in general. Now, the whole reason this can happen is because these strong trade winds push this water from east to west. But if those trade winds break down, what can happen is all this warm water on this side of the Pacific Ocean can kind of slosh back across and pile up on this side. And that's really what happens during an El Nino. What happens during El Nino is the trade winds actually weaken and break down. It's called the Southern Oscillation. What will happen is that water, that warm water, there's nothing to hold it back anymore, and it flows across the Pacific and kind of piles up over on this side of the Pacific, going all the way up toward California, all the way down to Peru and Chile. And we don't get upwelling anymore over here, and the atmospheric pressure patterns switch, and so what happens now is that warm water fuels rain and storms, and the trade winds are actually reversed in direction, and this part of the ocean now becomes the rainy, stormy side of the ocean. And so during an El Nino, we typically have very high rain, lots of storms and flooding over on this side of the Pacific from California on down to South America. Now, what usually happens within a year or so after the El Nino is that it's like the pendulum swings back the other way and we get a La Nina. La Nina really can be considered to be a sort of an intensification of the normal conditions. Remember, this is the normal situation where the trade winds are blowing all the water west and it's piling up over here. During a La Nina, the trade winds blow even more intensely, and even more cold water gets pushed west, and even more intense upwelling happens along the coast of South America. So it really is just an intensification of the normal situation. So the Pacific Ocean kind of oscillates between these two conditions, the El Nino condition in which the water sloshes over to our side of the Pacific, bringing storms and rain and warm water, and the La Nina condition in which the water goes back to the other side of the Pacific and cold upwelling becomes even more intensified. These cycles go back and forth, not particularly regularly, but anywhere from every 2 to 8 years is pretty typical.